This lecture will discuss about mass and mole fractions. Mass and mole fractions are used to determine the properties of a mixture. We need to know what that mixture is composed of and what are the various properties of individual components. So, suppose you have air, you know that it is made up of nitrogen, oxygen. So, you need to know its composition and how much of it is present in air. So, there are two ways in which you can describe the composition of a mixture, either by specifying the number of moles of each component, which is called molar analysis, or by specifying the mass of each component, which is called gravimetric analysis. So, first let us consider a gas mixture that is made up of K components. So, the overall mass of this mixture, which is denoted by mm, is the sum of masses of all the individual components, and mole number Nm is the sum of the mole numbers of all the individual components. So, let us say that we have K components, which means K different molecules are present in a gas mixture. So, mm is nothing but summation of I is equal to 1 to K mi. So, it is m1 plus m2 till mk. Similarly, nm is n1 plus n2 till nk, which is summation I is equal to 1 to K ni. So, the ratio of mass of the component to the mass of the mixture is called mass fraction mf, and the ratio of mole number of a component to the mole number of mixture is called mole fraction. So, mfi is nothing but mi by mm, and yi is mole fraction is ni by nm. So, next we can see the mass of a substance can be expressed in terms of mole number n and molar mass m. So, m is equal to n multiplied by m. So, small m, which is the mass, is nothing but molar mass multiplied by number of moles. So, then the average molar mass and gas constant of a mixture can be expressed as mentioned below. So, mm molar mass is mass divided by number of moles. You know that mm is summation of all the components mi divided by nm, and each component mi can be written as ni multiplied by mi. So, this overall can be written as summation I is equal to 1 to K yi mi, and Rm, which is the gas constant, is nothing but ideal gas constant divided by mm, which is the molar mass of the mixture. So, mass and mole fractions, both of it is related. So, you know that mfi is mi divided by mm, and mass you can write it as number of moles multiplied by molar mass ni mi by nm mm, and you know that ni by nm is nothing but the mole fraction yi. So, mfi, which is your mass fraction, is mole fraction multiplied by molar mass of the component mi divided by molar mass of the mixture. So, next is a small example. So, consider a gas mixture that consists of 3 kg of oxygen, 5 kg of nitrogen and 12 kg of methane. We need to determine the mass fraction, mole fraction of all the components, and average molar mass and gas constant of the mixture. So, first we need to find the total mass of the mixture, which is mm. So, here we have 3 components, oxygen, nitrogen and CH4. So, you add all the masses, 3 plus 5 plus 12 is 20 kgs. So, mm is 20 kg. So, mass fraction, you know the equation, mf is mi divided by mm. So, here I is oxygen. So, mf oxygen is MO2 by mm. So, similarly for nitrogen and methane. So, mfN2 is mN2 by mm, mfCH4 is mCH4 by mm. So, to find the mole fraction, we need to determine the mole numbers. So, how do you determine the mole numbers? Is mass divided by the molar mass. You know that mass is 3 kg and molar mass of oxygen is 32 kg per kilomole. So, then you can find how many kilomoles of oxygen, similarly nitrogen and CH4. You need to remember the molar mass values for different components. So, the total number of moles of the mixture Nm is, when you add all these 3 components together, it is 1.023 kilomole. So, next is finding the mole fraction. So, mole fraction of oxygen is NO2 divided by Nm. So, number of moles of oxygen divided by the total number of moles. Similarly for nitrogen and methane. So, if you add all these 3 together, the value should be equal to 1. Similarly, if you add all the mass fraction values together, it should be equal to 1. So, next is determining the average molar mass. So, molar mass mm is small mm divided by nm. So, mm is the total mass of the mixture, 20 divided by 1.023. So, that is 19.6 kg per kilomole. Similarly, for gas constant, you need to divide the ideal gas constant 8.314, that divided by your nm. So, that is 1.023. Then you can find the value of gas constant of the mixture. Thank you.